today I'm just going to quickly recap all of the key concepts which were discussed in our lesson today. So for those of you who have seen this before or were present in today's lesson, there will be no reason for you to have a go at the exercises unless you'd want some welcome practice. However, for those who weren't in, I would appreciate it if before every single question, if you could just pause the video and have a go yourself, then that would be really useful and really beneficial to your learning. So, we're going to start off by exploring the idea of a perpendicular bisector. Now, a perpendicular bisector comes hand in hand with the equation of a circle because any time we have a circle and we have a chord on that circle, the perpendicular bisector is going to go through the origin of that circle, or go through the centre point of the circle, let's say. So it's a really, really useful skill to know whenever we want to think about a circle and maybe a point at the centre. So in order to do this, I'm just going to show you two similar types of questions you could be asked. The first one would be find the perpendicular bisector of the line AB, where A and B have the coordinates and they're given as A is 4, 7, so let's imagine I've got my Cartesian plane and I've got point A here, and B is given as 10, 17, so it would be over here somewhere. In order for me to have a perpendicular bisector, I first of all need to understand what those two words mean. We should know that A and B could be drawn together by some segment, and if I want to perpendicularly bisect it, well, bisector is going to be splitting into two, so I would need to go through the midpoint, and perpendicular means that when they cross, it would have to form some sort of 90-degree angle. So to do this, I need to know some information about this segment AB. I need to know the midpoint, and I also need to know the gradient. The gradient will help me find the bisector. Okay, so first thing we're going to start off is with the midpoint. So looking at the line, the segment AB, I can find the midpoint by looking at the average of the x coordinates and the y coordinates. So the x coordinates are 4 and 10 respectively. So to find the average, I can add them together and halve it. And also the y coordinates are 7 and 17. So again, I can add them together and halve it. This would give me a midpoint of the line of 7 and 24 halved is 12. So I know that my perpendicular bisector goes through this point, 7, 12. The next thing I want to know is the gradient of this line. Well, to think of the gradient is how far up does it go when I move one section to the right or up one in the positive x-axis. So I go 6 across in the x-axis. So it's my difference in y. So it's 17 take away 7 over 10 take away 4. So it's a difference of 10 over 6. And that would be the gradient of my line segment, which would be 5 over 3. So therefore, my gradient of my bisector, I'm just going to put m with a subscript b, would be the negative reciprocal of that, so negative 3/5. I can combine these together now to work out the equation of the line with this gradient through this point by thinking about my formula y minus y1 equals m lots of x minus x1. This is just a rearranged version of this gradient formula I used here, and by substituting in my points, I get y subtract 12 is going to be equal to negative 3/5 of x subtract 7. And I can leave it in this form. I could rearrange it if I wanted to, however, I'm just going to leave it in this form. The next type of question, if we read it, I've got a line segment AB as the diameter of a circle, so I know this line here is the diameter of a circle, and I've also got a centre coordinate. What are the coordinates of B? I could go about this in a few ways, but the easiest way to think about this is to think about what's actually happening in this scenario. So what's actually happening is that, well, if it's a diameter, whatever I do to get to the centre, I'm going to have to repeat to get to point B. So from point A to the centre, my x-coordinate increases by 4. So therefore, from point M to B, my x-coordinate must also increase by 4, so this must be 9. And likewise with my y coordinate, it decreases by 2, so therefore it would decrease by 2 more. So therefore the coordinates of B can be written as 9 and -6, and I don't feel like I've had to do any complex maths. I've just had to think about what the question's asking me. Okay, so we're just going to quickly recap the area of a circle. Now, if you want to go into in-depth about where this comes from, I would point you to my previous video. However, the area of a circle just simply, the equation of a circle, just simply comes from looking at the definition of a circle with a said radius, and we would know that we'd be going in the x direction and y direction. If all points are going to be equally spaced around, then the equation of a circle centered at the origin would just be x squared and y squared would be equal to our radius squared. Moving on from this, looking at a circle which maybe isn't centered at the origin, I would like you to think about how could we make this circle centered at the origin by looking at our translations. We know that if we translate a shape, a direction to the positive x plane, to translate it backwards, it would be x subtract a. So instead of x squared, we just need to subtract our a squared, and we can do the same with b. And we get y subtract b squared, and our radius would be unchanged, so it would still be equal to our radius squared. So why is this useful? Well, this is a really useful way of coming up with the equation of a circle because we can read off our centre and our radius really quickly. Now, I showed you in the previous video that we don't always get given our circle like this. However, using completing the square, we can end up with our circle in this form. So I'd like you to just pause the video now and have a go at these questions. And I'm just going to show you all the answers just so you can see. And I'd like you to just quickly pause it again just to verify if you got these right or not. Just so you can see the bottom one. Okay. So now we're going to move on to some new content. So our new content is to think about how can we get the equation of a circle when we haven't even been given the radius or the centre. So this is what the hint is trying to explain to us, is that in order to get the equation of a circle, it's really easy if I know the centre value and I know what the radius is. So looking at this example, we've got a line segment AB and it's the diameter. Because it's a diameter, we know it goes through the centre. With coordinates 5, 8 and -7, 4 respectively, determine the equation of a circle. Okay, so to get the centre point, hopefully it's self-explanatory that I want this point of a centre of these two values, so I'm going to find the midpoint of these. So again, I'm going to find the average of the x coordinates and the average of the y coordinates, which would be 8 add 4 over 2. So therefore my midpoint must be -1 and 6. In order to think of the radius, well, I could use this -1, 6 that I found out already. So I know this is -1, 6. If I draw a triangle to a point, let's say A, I know that my hypotenuse is going to be my radius. My x direction, I've gone from -1 to +5, so I've gone 6 units in the x direction. And in the y direction, I've gone from +6 to +8, so I've gone 2 units. So using Pythagoras, I know that my radius is going to be 6 squared add 2 squared, square rooted. 36 add 4 is 40, so my radius is going to be the square root of 40. I'm not going to try and simplify that yet, because let's think about how I actually need this. I'm going to think about my equation of a circle. X minus a squared plus y minus b squared equals our radius squared. So therefore, substituting in our coordinates, we're going to get x plus 1 squared plus y subtract 6 squared equals, well, if our radius is root 40, our radius squared is just going to be 40. And that would be enough to get full marks on this question. So, I'd like you to have a go at this question here, please. So pause it now and have a go. And hopefully, after you've done this question, you should find that we're going to get a 5 add 13 over 2, and we're going to get negative 1 add 11 over 2. So therefore, this would be 18 over 2, which is 9, and negative 1 add 11 is 10 over 2, which is 5. So that would be the centre. Given that is the diameter, find an equation. So in order to find the equation, we need the centre, and we also need the radius. So thinking about the radius, it's going to be the square root of, well, from 9 to 13, I have to add 4, and from 5 to 11, I have to add 6. So it's a square root of 36 at 16, which is 52. Substituting it into the original formula, we're going to get x, subtract 9 squared, plus y, subtract 5 squared, and that's going to be equal to our radius squared, which will leave us 52. Please verify your question, and if there's any corrections you need to make, please make them now. And we're finally going to finish at a certain type of question which comes up quite a lot. Now, we have done these questions during GCSE mathematics, but maybe we haven't done them to the extent or using the knowledge which I'm about to share with you now. When we thought about the intersection point of two lines, we could think about 3 different scenarios that could happen. I've tried to outline them here below. The first scenario is that, well, the equation of a circle and the line just don't cross at all. That would mean we would have 0 intersection points. So thinking about the discriminant, that means there would be 0 solutions. When we thought about the 0 solutions, that means b squared minus 4ac. Well, if that's under a square root sign, in order to have no real solutions, it must be negative. So therefore, b squared minus 4ac must be less than 0 for it to have 0 intersection points. For there to be 1 intersection point, that means that my b squared minus 4ac must be equal to 0, because that would form a tangent. So that must be equal to 0. And lastly, if I get the standard example where it's 2 intersection points, that would be that my b squared subtract 4ac would be greater than 0, meaning that when I do my plus or minus square root, I would get 2 distinct answers. And we call this a secant. And as pointed out in the session today, that is because you have split it up by a chord and created sectors. So why is this useful? Why is this good? Why is this going to help us with a question involving straight lines, which doesn't seem to have any quadratic in at all? So looking at this, show that the line y equals x plus 3 never intersects with a circle with equation this, x squared plus y squared equals 1, which is our unit circle, coincidentally. Well, if it's got no intersections, I'm looking at this scenario of b squared subtract 4ac is less than 0. If I can show that, then I can show it's going to have no real solutions. So in order to do this, I'm going to solve these simultaneously. I already know y equals x plus 3, so therefore when I substitute it in for my y value, that's going to give me x plus 3 squared equals 1. I'm starting to see a quadratic drop out now because I've got x squared. Expanding this is going to give me x squared plus 6x plus 9 equals 1. And now if I want to think about a quadratic, we only really ever solve these when they're equal to 0. So tidying this up a little bit, I get 2x squared plus 6x, and then if I subtract the 1 across, it's going to be plus 8 equals 0. Making it easier for myself by dividing 3 by 2, I end up with x squared plus 3x plus 4 equals 0. And now I'm going to think about my discriminant, this b squared minus 4ac, because this is going to be telling me the nature of my intersection points. So in this scenario, a is equal to 1, b is equal to 3, and c is equal to 4. Therefore, b squared minus 4ac is going to be equal to 3 squared, subtract 4 times 1, and then times c, which is 4. 9 subtract 16 is negative 7. Therefore, b squared minus 4ac is less than 0, so no intersection point. is less than 0, no intersection. Okay, that would conclude today's session. If you have any queries or you want to maybe verify any things that I've said in this video, please, I'm more than welcome to responding to an email or if you want to write a comment. But thank you for watching, and I'll